Good morning, everybody. In last lecture, we have seen hydraulic pumping basic part. Hydraulic pumping is like this. One surface unit must be there. Okay, surface unit will be delivering high pressure fluid to your wellbore. This is my casing. This is my tubing. Okay, and tubing maybe will have packer. Then you inject high pressure fluid through tubing, get production through your annulus. Okay, so high pressure fluid, this is HP fluid. Okay, and how high pressure fluid you are getting, whatever production you get, so that produced fluid you for condition means you remove unnecessary particles or fluid or gas, whatever is there, then you create high pressure using multiplex pump. Okay, so multiplex pump means there will be several cylinder pump. Later we'll discuss what is multiplex pump. So from there you store high pressure fluid in a tank. From that tank you inject high pressure fluid into your wellbore. Okay, when you are injecting, there is one pump. This is called hydraulic engine pump or jet pump. Hydraulic jet pump or hydraulic engine pump. So that pump works because of high pressure fluid you are pumping from the surface, and it is creating low pressure or flowing pressure. It is creating low flowing pressure. So because of that one, you are getting more production. How low flowing pressure is created? I already told that there will be flow rate and PWF, flowing pressure. And if you draw the IPR curve, it is like this. So initially, let's assume my curve was there, the outflow performance relationship or tubing performance relationship, and because of this jet pump you reduced hydrostatic pressure or PWF. Because of PWF reduction, your point become here A to B. Okay, so because of this pressure change, you are getting actually more flow rate. Q increased, you can see this one, and your pressure is changed. Actually flowing pressure is reduced, so you are getting more flow rate or production fluid. So to get this more flow rate, you have to select proper artificial lift. Proper artificial lift means there will be several criteria I already discussed. Later again at the last lecture I will discuss again further. You finally decided that you are going for a hydraulic pumping. The hydraulic pump, we have two options, one will be hydraulic engine pump or hydraulic jet pump. So in this lecture I will discuss hydraulic jet pump, hydraulic engine pump. Jet pump we will discuss later. So what is hydraulic engine pump? Hydraulic engine pump, actually you have one reciprocating engine and it is connected to your pumping unit. Okay, so this is engine, this is pump. Okay, and it is connected to one rod or connecting rod, you can say. Okay, and you can remember the sucker rod pump. Sucker rod pump, how does it work? Sucker rod pump will have one like this one beam is there. Okay, and this is driven by some motor mechanism. Okay, and there is one horse head. From horse head your polish rod is going, then you are having sucker rod and you have plunger assembly. Okay, plunger assembly. Okay, now what you are doing here, you are giving reciprocating motion. So what is this doing? Reciprocating motion in sucker rod pump or beam pump? Beam pump or SRP or beam pump, or many names are there. So this sucker rod pump, actually you are creating reciprocating motion. You follow previous lecture, and this reciprocating motion is running on traveling valve, standing valve, and that way you are getting production. In hydraulic engine pump also you have that bottom hole assembly, plunger, traveling valve, standing valve assembly, and that is giving you production. But that assembly is not run by your rod, long sucker rod. You have only small rod And hydraulic engine, this engine, how it is working, I will explain later. This engine is run by your hydraulic fluid. Okay, this is high pressure fluid. High pressure fluid, how we are getting? You are pumping from the surface. I already told that on the surface there is one high pressure pump, or duplex, simplex, triplex, different types of pumps are there. So normally multiplex pump will be used to create high pressure. That high pressure you are pumping through this pipe, and maybe annular or tubing, or a separate tubing also you can insert. So that will be running your engine, certain type of engine, I will explain later. Okay, so that engine will create a reciprocating motion of this rod. Okay, this rod will get reciprocating motion, this one. Okay, this rod, you see this, I made completely red color. So this will get a reciprocating motion. So that reciprocating motion will run your pump actually. Okay, so you will have traveling valve, standing valve. Okay, in sucker rod pump also you can remember, we will have one plunger, traveling valve, and one standing valve. So this is traveling valve, this is standing valve. Okay, so here also I have traveling valve, I have one standing valve. Okay, and I have one plunger. Here also I have plunger. I have one rod, I have an here rod. But in my hydraulic engine pump, this one hydraulic engine pump, here I have short sucker rod. Okay, it is having short sucker rod, or you can say only connecting rod. Okay, so this one short sucker rod, actually this one. Okay, this one. Basically the function same. For pump part, engine part I will explain later. So pump part is having one traveling valve, standing valve, when piston moving up, standing valve opening, a traveling valve delivering fluid, and piston or plunger moving down, standing valve closing the path, and fluid is going up. Okay, that way the pump part is working. And this hydraulic engine pump, the pump end, this is called pump end. Okay, this is called engine end. Engine end. Okay, and this is run completely by fluid. There is no long sucker rod, especially it is having only connecting a rod. Okay, and this because this is completely assembly, like engine and pump together, you can insert very long wellbore also. And this is functioning similar as sucker rod pump, so its flow rate also low. And the problems, whatever sucker rod facing, similar problem it will also face. For example, gas lock or gas interference issue it will be having, but long rod breaking and other thing, that is not there because rod is anyway short. But other problem will be added here. Hydraulic engine is here, so that engine will have other problems. But the gas related issue, sand related issue, flow rate related issue, it will be resembling as sucker rod pump bottom hole assembly. And definitely it is not having this surface unit such as beam, nodding donkey, that horse head. You don't have pitman arm, all these things are not there. But on surface you have one fluid system. Okay, fluid to create high pressure. That high pressure fluid coming down through your tubing, or maybe separate tubing insert, and that fluid, high pressure fluid, will be driving the engine, and you are getting production. Okay, now the term I said, sometime simplex, sometime duplex, or single acting, double acting pump is in the system. So what is single acting pump? You have sucker rod pump, all right, and barrel is there, and this is plunger and traveling valve. Okay, this is barrel, you can remember. So for sucker rod pump, barrel, this is standing valve, this is traveling valve. Okay, I hope you can remember. this is plunger, okay, this is rod will be moving up and down, and SV and TV will be acting continuously, plunger will be moving up and down, and you will get production. So during upstroke only you are getting flow delivery, during downstroke SB closed, so fluid not entering, so only during one stroke you are getting production. Okay, so this is single stroke pump, single acting, okay, single acting pump. But in many cases people try to develop double acting pump. How double acting pump work? Because single acting pump is only one time production is there, when plunger is going down no production, plunger moving up production, no production, production, no production. So my pressure pulse will be like this, okay. If I see pressure, this is time, with time this much of fluid be delivered, pressure will be increasing, again there is no pressure when plunger going down, again pressure, again pressure, so that way you are giving pressure pulse, okay. But if I can create double acting pump, how double acting pump work? I'll draw it horizontally, okay. Say I have one plunger here or piston, okay, and in single stroke pump, single acting pump, normally we will have one valve here, one valve here, okay. And this single acting pump I am explaining here because this basic fundamental thing will be used in the next lecture when we will discuss about pumps and compressors, okay. So here let us say this is valve 1, this is valve 2, this is plunger, this is rod, okay, piston rod, this is piston or plunger, okay. Now when piston is moving A, B, okay, rod is moving B to A, rod moving B to A, okay. So when B to A moving, what is happening? When B to A moving, B to A, rod piston is moving left, right to left, okay. So that time V1 will be opening, V1 open, V2 closed, okay. Okay, so fluid will be entering, V1 is open and V2 is open, V2 okay, V1 is open, V2 I have to make like this, it is sucking, so it will be closing this, okay. So V1 open, V2 close, okay. So what will happen, whatever fluid is there, it will be entering here, so fluid will enter into the cylinder, okay. Now rod moving A to B, okay. When A to B, piston is moving left to right, what is happening? So V1 closed, V2 open, fluid exits through V2, okay. Fluid exits from through V2, okay. So this is single acting. So when plunger is moving A to B, only you are delivering, B to A no delivery, it is taking fluid inside cylinder, again pushing, delivering, like your cycle pumper. I have given example, I think I can you can see the lecture, cycle pumper, when you are pushing it down, so that time you are delivering to your cycle tire, when it is moving up you are not delivering, you are sucking fluid from atmosphere or surrounding, then again pushing, so one time pushing, so intermittent flow this one, okay. Now if you want to avoid this intermittent flow and you want to make more continuous flow, so what do? You create double acting piston. How double acting piston works? Okay, it will be like this. I'll draw similar figure, okay. and here I will have a sealing arrangement, and my piston is here. Piston will have very limited clearance. Okay, piston I'll make shading. Okay, that is better. Okay, same piston I am drawing, and I have valve same V1, same here V2. Okay, okay, okay. So this one A, this end is B. This is again piston. This is single acting. This is double acting. Okay, how double acting is working? Let's say piston is moving, rod again. This is piston rod. Piston rod again. First B to A. B to A, piston rod moving, right? Or rod or piston moving. What is happening? B to A moving means same phenomena will happen. V1 closed, V1 open, V2 closed. Okay, fluid enters cylinder. Okay, and opposite happen A to B. When A to B is there, what is happening? V1 closed, V2 open. So what happens? Fluid exits through V2. Now I said double acting, but I wrote as it is same as single acting. You see left side picture, single acting and double acting, I wrote same thing. Now what is the difference? Difference is that here, when piston moving B to A, there will be some more valve here nearby A end. Okay, one valve will be when piston is moving this side, so this is sucking, so the delivery will be happening here. Okay, inside like this will be opposite valve like this, like this. So V1, V2, so V1 entry, I'll make a random thing, V3, V4. Now what is happening in V3? Okay, when rod is moving B to A, left to right to left, so one side flow entering, and this cavity, I am putting dotted here, lots of dots are, I am assuming this is filled with liquid. Okay, this cavity filled with liquid. So what will happen? Rod B to A moving, so that time this fluid will be going out. Okay, through valve V4. V4 open, V3 closed. Fluid enters the cylinder. I have to give name of cylinder, maybe 1, 2. Okay, the cylinder 1. Close V4, fluid exits from 2, cylinder 2. From cylinder 2, fluid is going out actually. So when piston is moving B to A, there are two cavity, two cylinder, 1 and 2. So 1 is filling, 2 fluid delivering. Okay, now opposite happening, A to B, V3 open, V4 closed. Okay, fluid enters at 1, at 2. Okay, A to B sequence happening, piston moving A to B. So that time fluid entering into cylinder 2. So now you see, when piston moving left to right, one cylinder delivering, one cylinder taking fluid, opposite. So one again same thing happening, one taking, one delivering. So what is happening now? Let's say sequence 1, A to B, I am getting pressure pulse like this. Okay, you see the pressure pulse on the screen. Now when B to A, I am getting pressure pulse like this. Okay, so my pressure pulse become almost smooth. Now I have, this is double acting. Now or single acting, they call simplex sometime. If you have multiple cylinder, then that pressure pulse can be smooth also. But anyway, for my hydraulic engine pump, here normally single stroke or double stroke engine can be used, or single stroke pump, double stroke pump also can be used, so that you can get one pulse, two pulse continuously when piston moving up. This you can see this rod one, this red color rod I have drawn here. This rod is moving up, delivering, pump is delivering, rod moving again, pump delivering. So both side pump delivering. Okay, so double flow rate you are getting. Okay, but in SRP you are getting flow during upstroke only. Okay, so but you can create a single stroke or double single acting or double acting, doesn't matter. I mean, it is your choice or based on your decision. Now you see the pump is having single acting, double acting action. Similarly, you will have engine side also single acting, double acting. How? Okay, so engine side will also having same thing. Okay, I have one piston. Okay, and I have high pressure fluid entering here. Piston is connected to your pump piston. Okay, piston must be connected to your pump piston, and there will be one sealing arrangement. Okay, now how this work? I'll shade this metal part with this cross sectional area. Okay, and I will have one valve here. Okay, so I'll shade everything. Here also I am shading because this is cross sectional area. If you go through engineering drawing, so the cross sectional area we create shading with slant lines. Okay, I am not showing cross section of piston and piston rod. Okay, this is my pump, this side my pump end. Okay, this is piston engine end. Okay, now when I have valve here, okay, V1, I will put some num V1 VE, valve of engine 1, valve of engine 2. Okay, so what is happening? Let's put high pressure fluid from the top through valve 1. Okay, when high pressure fluid is entering into your cylinder, this cylinder will be pressurizing the surface. Okay, surface okay, on the surface. When surface is getting pressurized, the surface will be trying to push down the rod. When pushing down rod, your this piston will have all the sucker rod pumping mechanism, right? Similar way, sucker rod pump we assume. Okay, this plunger assembly is there bottom. Piston is moving down and your fluid is entering and it is going through this. Okay, produced fluid. Okay, produced fluid or wellbore fluid, and this fluid is power fluid. From where power fluid coming? It is coming from the surface. At high pressure pump we have on the surface, so that pump is delivering high pressure fluid. So that fluid is pressurizing a piston. Piston is moving down. So that piston is connected to your plunger assembly for pump. So pump will be delivering fluid when piston moving down, pump delivering when piston moving up. Okay, engine piston and your plunger for pump both are moving because those both are connected, so both will be moving together, right? Moving down, it is delivering. When moving up, so how it will move up? You close V1 engine piston or plunger. This is called a hydraulic piston pump or hydraulic plunger pump, hydraulic piston engine, okay, or hydraulic engine pump. This is the engine piston. What will do? High pressure fluid is getting a power fluid, high pressure fluid or power fluid, or motive fluid also. Sometimes they say motive fluid. High pressure fluid enters through VE1. Okay, when so what is happening? Piston engine. Okay, I am saying, just I am giving random name. Piston engine moves down. So that gives pump piston or pump plunger, you can say. Pump piston moves down. Okay, so together moving down. Now you close valve V1. Now next, close VE1, open VE2. Okay, so whatever high pressure fluid was there in cavity 1, so fluid from cavity 1 will exit and will reach to surface. Okay, so whatever fluid exiting through VE2 through maybe different tubing, so that fluid will have lower pressure, because let's say pressure 100 bar pressure you have given, because it was pushing down to pump, so some pressure it is already given to pump. Okay, now it is having remaining low pressure. Okay, so that low pressure fluid will be moving up to the surface. Again you re-inject the same fluid and continuously that fluid will be going on. And in pump side also same thing will happen. Now if you create double acting piston, so again high pressure cylinder, you will have valve here. Okay, VE3 will be there and one VE4 will be there, VE4. Okay, so when it piston moving down, V3, VE4 is not working. Not working means it is not creating any pressure. Okay, it is just allowing fluid to go out. Okay, when piston is trying to move up, so what you do, you open V3, then create pressure from the bottom of the piston. Okay, so I will write here. So for double acting, this is single acting. Okay, so when you are creating double acting, so high pressure fluid piston moving up, PE moving up. When during piston moving up, V3 E3 delivering high pressure fluid, to chamber 2 or the vacuum, that area, the location 2, it is getting filled up, or it is creating very high pressure. So because of high pressure, piston moves up. So PE piston, okay, already I have written PE piston moves up. Okay, so that time what is happening, you are getting high pressure fluid, PE piston moving up. Okay, when again piston is moving down, opposite thing will happen. Cavity 2 fluid exiting and cavity 1 getting filled with high pressure. So high pressure creating, piston moving down. Again bottom you are creating very high pressure, piston moving up. So continuously you are operating two valves. Actually there will be some mechanism so that you can automatically, the valves will be operating, one valve open, another valve close. So 4 valve will be working simultaneously, so that you can get continuously piston moving up and down. So that piston moving up and down, you are getting plunger, the pump plunger also moving up and down, and pump also you can create double acting pump. Okay, so you see my previous section of this one. So how single acting, double acting is working, the same way the engineers will be designing and you will be delivering fluid. And because this is short pump, short means less than sucker rod pump or beam pump. So you can go very long depth because you don't have very long sucker rod, which will create surface motion and other issues. Okay, again it is low flow rate pump, gas will be having problem, sand will be having problem. Normally it will not be used for your gas well deliquification because high gas volume it will create issue. And if you have very high piston volume, piston speed, that also creates very much trouble. Major failure occurs because of excessive high piston speed. So if very high speed is there, then you have to control your pressure from the surface and you have to reduce the speed. And there will be sealing section here, metal to metal seal. Sometimes elastomer and other seals also can be used. Normally metal to metal seal will be there. So if a very high amount of leakage is there, then your power fluid and produced fluid, that engine side power fluid will be there, pump side produced fluid is there, they will be mixing up. So normally there will be on sealing section here, seal, so that both fluid will not get mingled up. Piston size, normally 2.5 inch tubing, 2.5 inch tubing, there will be piston size like 134 inch, 158 inch, 1/2 inch, 1/14 inch, 1/16 inch. So this sort of size of piston can be used for a 2.5 inch tubing.